ఈరోజు 11th బుజ్జి డేట్. ఇదేనా? Good evening to all. Am I audible? Is there any disturbance in my mic? Am I audible? Please mention in the chat box. If you have not had your supper, you can attend the class while having your supper. It doesn't matter. Huh? Someone has mentioned you have not yet have your supper. You can have your supper. While having your supper, you can listen to the class. Huh? Okay, let us start this lecture. So, whatever manual that is available in my channel. So, the manual that is available in my channel, for that manual, I have written these calculations. So, theoretical calculations for that particular manual. So, for that particular circuit which is mentioned in my channel. So in this today, we will discuss the theoretical calculations of the laboratory manual for the verification of Kirchhoff's voltage law and Kirchhoff's current law, which is available in my channel. So let us see what is that circuit for which we have to do the theoretical calculations. So this is it. So theoretical calculations to verify what? Kirchhoff's voltage law for the given circuit. So this is a given circuit. So you can see here. There is a voltage source whose notation is V1 and voltage value is 30 volts. There is another voltage source V2 whose voltage value is 30 volts. And there are three meshes you can see. This is one mesh, this is one mesh, and this is one mesh. So you can mention in the chat box. Whenever if I ask anything, you can mention. So how many meshes are there? So this is one mesh, this is another mesh. Total 3 meshes are there. Okay, in the given circuit. So since there are 3 meshes, we can consider 3 loop currents. So if I assume this first one as mesh 1, okay, I can write mesh 1 here, and then I can assume a loop current I1 here, okay, and if I consider this mesh as mesh 2, I can assume a loop current I2 in this mesh. Similarly, if I assume this is my mesh 3, so I can assume a loop current of I3 within the mesh. Okay, so total 3 meshes. So 3 loop currents I have assumed. Now this loop current should have some direction. So I can assume any direction here for these loop currents. So here for the first loop current, it's our wish. You can assume either clockwise or anti-clockwise. I am assuming clockwise direction for this loop current I1. Similarly, for this loop current I2, you can assume either clockwise or anti-clockwise. Here I am assuming, sorry. for I2 I am assuming anticlockwise. So why I have assumed for I1 clockwise and for I2 anticlockwise. The reason behind that is, if you observe here, the positive terminal is upward for V1 here. So that's why I have assumed I1 current upward. See, this is upward, isn't it? Similarly, this is my positive terminal of V2 here. So current will come out in upward direction. That's why this side I have assumed for this loop current, this side I have assumed upward. So when I assume upward in this side, it definitely current will flow in anti-clockwise direction. If I assume this direction, I will take the laser. So see here, the positive terminal is upward for V1. I will erase that. So positive terminal is upward. That's why I have assumed the current direction besides to this positive terminal as upward for I1 loop. If this is upward, then definitely on the other side should be downward. So this current is in clockwise. And here positive terminal is upward for V2. Therefore I2 current, loop current direction besides to this positive terminal I have assumed upwards. If this is upward, definitely the current will flow in anti-clockwise direction. So no need to follow this, but I have followed that rule. No need to follow. You can assume either clockwise or anti-clockwise, your wish. Okay. Similarly for I3 loop current, you can assume current in either clockwise direction or anti-clockwise direction within this loop. Okay, or within this mesh 3, there is no source, isn't it? I will take the laser. Cursor is not visible properly. Within this mesh 3, there is no source. So there is no source. Therefore, blindly you can assume the current direction in your wish, either clockwise or anti-clockwise. So I usually prefer clockwise. I have decided to assume the I3 current as clockwise. So first of all, for the theoretical calculations to verify KVL, so we must see how many meshes are there. So mesh 1, mesh 2 and mesh 3. Total 3 meshes are there. So you just identify the meshes. After that, assume the loops. Okay, just draw the loops in each mesh and write the loop currents I1, I2 and I3 and give directions to those loop currents, either clockwise or anti-clockwise. I will erase all the inks. Okay. So first of all, we must draw this circuit. Okay. So this is the given circuit. We must draw this circuit. After drawing this circuit, okay, after drawing this circuit, what we have to do is we have to assume the loop currents. Okay. So these are the loop currents which earlier I have drawn in the other slide. So you can see here I have written here mesh 1, mesh 1, mesh 2 and mesh 3. Total 3 meshes, 3 closed paths, isn't it? This is one closed path. This is one closed path. This is another closed path. So 3 meshes are there. So 3 loop currents. Okay. I1, I2 and I3. And I1 loop current is in clockwise direction or wish. You can assume either clockwise or anti-clockwise. I1 loop current is in clockwise. I2 loop current is in anti-clockwise. I3 loop current is in clockwise. So in whichever direction that you want, you can assume the loop currents. Okay. Now, let us write the loop equations. Okay. Let us apply KVL in each mesh. Okay. And let us write the loop equations. So I will just wait for a minute. So if anyone is writing it down, you can write it down. Okay then. If you are drawing and if you have completed, please mention. Please mention. So one more thing that I would like to discuss is in loop 1, that is mesh 1. Okay. So we should to be more specific, we should not call it as loop. We must call it as mesh. Okay. So in mesh 1, what are all the elements are there in mesh 1? Voltage source V1, resistor R1 and resistor R2. In mesh 2, what are all the elements that are there in mesh 2? Voltage source V2, resistor R4 and resistor R3. Now what are all the elements that are available in mesh 3? Resistor R5, resistor R3 and resistor R4. So this is it. Now let us apply KVL in each mesh. Okay, and let us apply KVL in each mesh and okay, let us apply KVL in each mesh. Now let us apply KVL in mesh 1. So what did I say in mesh 1? What was there? There was voltage source of 30 volts. There was voltage means there was R1 and R2 was there. I will just copy that image here so that it will be easy for you to understand how to write the KVL equation. So if you see here, we are applying what? We are applying KVL. We are applying KVL in mesh 1. So in mesh 1, what is there? V1 is there, R1 is there and R2 is there. Okay, in mesh 1, V1, R1 and R2 is there. So when we apply KVL, we know that algebraic sum of source voltages in a closed path must be equal to the algebraic sum of the voltage drops in the closed path. So this is our closed path. This is a mesh. In mesh 1, how many sources are there? Only one source. So 30 is equal to what? Voltage drops. How many voltage drops will be there? 2 resistors are there. So algebraic sum of the voltage drops across each resistor. What is the voltage across R1? VR1. What is the voltage across R2? VR2. Okay. So algebraic sum of voltage sources. Only one voltage source is there. So that voltage source value is 30. 30 is equal to what? Voltage drop across R1 and voltage drop across R2. Okay. So now, so what is VR1? What is VR1? VR1 is the voltage across R1. VR1 is the voltage across R1. So what is the voltage across R1? V is equal to what? I into R. Okay. So what is R value? 2000. R1 value is how much? 2000. So R is over. What is I value? What is I current flowing through R1? If you observe carefully, R1 is between mesh 1 and mesh 3. Okay, R1 is between what? Mesh 1 and mesh 3. Therefore, if you observe I1 current, here see upper side you just observe current direction is okay. So current direction is in this direction. Okay, you just observe I2 current. I2 current direction is this is the direction. Now observe these two directions. This is right side. Okay, I will just take the laser. This I1 current is pointing towards right side. I3 current is pointing towards left side, isn't it? So these two currents are not in same direction. They are opposite to each other. The direction of I1 and I3 is opposite to each other. Okay. So the difference of I1 and I3 will flow through R1. Okay. So what is R1 value? 2000. R into I. I is what? I is the differential current. Because R1 is between mesh 3 and mesh 1. Therefore, 2000 into, now we have considered mesh 1. Therefore, I1 minus I3. You must write I1 minus I3. Why I1 minus I3? Why? Because now we have considered the KVL in mesh 1. Since we have considered the KVL in mesh 1, therefore, that current will dominate the other current. So, I1 minus I3. Okay, plus, what is the voltage drop across R2? VR2. What is VR2? I into R. R value is how much? 1000. Okay. Voltage across resistor R2. So, resistance is 1000 plus, resistance is 1000 and into what? Into current. What is the current here? Just see, R2 is between what? Mesh 1 and mesh 2. R2 is between mesh 1 and mesh 2. What is the current of both I1 current and I2 current will influence the voltage drop across this resistor R2. So, what is the current direction? I1 is downward. I1 current is downward. What about I2 current? It is also downward. So both the directions are same. Both I1 current direction. Okay, see, I1 current direction is how is it? Downward. I2 current direction is downward. So both current, I1 current, I2 current directions are same. Since I1 current, I2 current directions are same, therefore voltage drop across R2 is what? 1000. R2 value is 1000. 1000 into sum of I1 and I2. Okay. So VR2 is what? 1000 into I1 plus I2. Okay. What is VR1? VR1 is 2000 into I1 minus I3. Okay. So that is equal to 30. So if anyone is unable to understand and if you want me to repeat any concept, you just mention in the chat box. I will repeat it. I am trying to explain in the simplest possible way, as simple way as possible. Okay. So if you are unable to understand, you can ask me. Now, so we have written this 2000 into I1 minus I3 plus 1000 into I1 plus I2 is equal to what? 30. Now expand 2000 into I1 minus I3. What is it? 2000 into I1 minus 2000 into I3. Expand this term. Okay, this term has been expanded. This term, if you expand, what do you get? 2000 into I1 minus 2000 into I3 plus 1000 into I1. Okay, 1000 into I1. What is this? Expand it. Plus 1000 into I2 is equal to 30. Okay. Now add all I1 terms. What are all the I1 terms are there here? What are all the I1 terms? 2000 into I1 plus 1000 into I1 is there. So 2000 plus 1000 I1, what is it? 3000 I1. Next, plus 1000 I2 plus 1000 I2 minus 2000 I3 is equal to 30. Consider it as equation 1. Okay, if anyone wants me to repeat, you can mention so that I will repeat it. Okay. So if anyone is noting it down and if you don't know, I am not giving sufficient time to write it down, you can write it down later. So now let us write down the KVL equation for mesh 2. For that I will copy the circuit from the other slide and I will show it to you. Okay. Now this is our circuit. Now let us apply KVL in mesh 2. Let us apply KVL in mesh 2. So in mesh 2, what is there? In mesh 2 elements, what are all the elements are there in mesh 2? Voltage source V2, R4 and R3 are there. Okay. So according to KIRCHHOFF'S voltage law, what is the statement? Algebraic sum of source voltages in a closed path must be equal to the algebraic sum of the voltage drops in the closed path. So how many voltage sources are there here? Only one voltage source. What is that? 30 volts. So 30 is equal to what? Okay, I'm sorry. One more resistor is there. I forgot. That is R2. So 30 is equal to what? Voltage drops across all the elements in this mesh 2. What are all the elements that are there? R4, R3 and R2 are there. Okay, total 3 resistors are there. So voltage drop across R2 plus voltage drop across R3 plus voltage drop across R4 is equal to what? 30. Okay. Okay. So what is it? 30 is equal to, okay, 30 is equal to what? Voltage drop across R2 plus voltage drop across R3 plus voltage drop across R4. Total 3 elements. Okay, 3 passive elements. Okay, 3 voltage drops. Okay, so that's why VR2 plus VR3 plus VR4 equal to 30. So what is VR2? What is VR2? R2 is between what? Mesh 1 and mesh 2. So what is R2 value? 1000 plus, I have already told you, I1 is downward and I2 is downward. Both the currents are both loop current directions are same. Therefore, you must add the loop current value. So 1000 into I2 plus I1 plus, next is what? VR2. What is VR2? This is R2. Oh, so this is R3. Sorry, not VR3. Now, next is VR3. So what is R3 value? 1000. R3 is between what? Mesh 3 and R3 is between mesh 3 and mesh 2. Now let us see the current direction, loop current direction. This current I3 is in this direction, I2 is in this direction. How are these two directions? Both are pointing towards left side, isn't it? So these two directions are same. Okay. See, I2 current direction is this. I3 current direction is this. Okay. So this is our R3. Okay. This is our R3. So how are the current directions? I3 and I2 both are same. Okay. Therefore, voltage across R3 is what? 1000. R3 value is 1000 into, what is it? I2 and I3 currents are same. Therefore, I2 plus I3. Okay. I2 plus I3 plus one more resistor is there. What is it? R4. One more resistor is there. R4. I will erase all links. So now, what is the current flowing through R4? R4 is not between any two meshes. It is only restricted to mesh 2. It is only in mesh 2. So what is the current in R4? I2 current will flow in R4. So what is it? VR4 is equal to R4 value is 1000. VR4 is equal to R value 1000 into what is the current? I2 is equal to 30. Okay. Now expand this equation. 1000 into I2 plus I1, how much is it? 1000 into I2, just expand it, plus 1000 into I1. That's it. Next, plus 1000 into I2 plus I3. How you just expand it, what do you get? 1000 I2 plus 1000 I3 plus you can't expand this, you have to write it as it, plus 1000 into I2 is equal to 30. Okay, is equal to 30. Now just add I1 terms. What is it? 1000 I1 and nothing is there. Okay, 1000 I1, write it as it is. Now add I2 terms. What are those I2 terms? 1000 I2, one more 1000 I2 and one more 1000 I2. Total 3. Okay, total 3 terms. So total 3000s are there. So 3000 I2 plus what is left over? 1000 I3 is left over. 1000 I3 is equal to what? 30. Okay, so this is it. I'll just remove this circuit. So I'll just give you a minute. If anyone is copying it down, you just copy it down. If you complete, you can mention in the chat box so that I can proceed. If you have completed writing the equations, you can mention in the chat box. So if you are able to write the KVL equations for each loop, you can even write those equations in the chat box. Okay, completed. Okay then. Now let us go to mesh 3. 3 meshes are there. Now I will just copy that image here. Now let us apply KVL in mesh 3. KVL in mesh 3. So in mesh 3, what are all the elements that are there? R5 is there, R1 is there, R3 is there. There is no voltage source in the in this mesh 3. No voltage source in mesh 3. Therefore, voltage drop across, I will erase everything. Voltage drop across R1 plus voltage drop across R3 plus voltage drop across R5 is equal to what? 0. So VR1 plus VR3 plus VR5 is equal to what? 0. There is no voltage source in this loop. Therefore, algebraic sum of voltage drops must be equal to, in a closed path, must be equal to 0. Okay, algebraic sum of voltage drops in a closed path must be equal to 0. So VR1 plus VR3 plus VR5 is equal to 0. Okay. So now what is VR1? What is VR1? VR1 is the voltage drop across R1. What is R1 value? 2000. So 2000 into current. How much is the current across R1? See, just observe here. The R1 is between mesh 1 and mesh 3. So I1 current direction is this. I3 current direction is this. So I3 current direction. This is the I3 current direction. I will just erase once again. I will. Ah. This is the I3 current direction. I1 and I3 current directions are opposite, as we have already discussed. Okay. So what is the VR1? What is VR1 value? VR1 is what? 2000. Resistance R1 value is 2000. Okay. 2000 into I3 minus I1. Okay. Why I3 minus I1? I1 and I3 both are in opposite direction. Why I3 minus I1? Why? Because now we are writing the mesh equation of third loop. Okay, mesh 3 loop. Okay, so we are writing KVL in mesh 3. Therefore, I3 minus I1 plus what? VR3. What is VR3? This is our VR3. So, VR3. So, where is R3? This is our R3, not VR3. This is our R3. So, R3, what is the R3 value? It is 1000 ohms. R3 is 1000 ohms. So, what is the voltage across R3? R value is 1000. What is current? Current R3 is between mesh 3 and mesh 2. Okay. R3 is between mesh 3 and mesh 2. Therefore, let us see the loop current direction. I3 direction is this. I2 direction is this. So I3 and I2 both directions are in same direction. I3 and I2 directions are same. So both I3 and I2 directions are same means you can add those two currents. So R3 voltage across R3 is what? VR3 is equal to 1000 into I2 plus I3. Okay, 1000 into I2 plus I3. Okay, plus. Okay. Now let us see the voltage across R5. Voltage across R5. What is voltage across R5? Where is R5? This is R5. So R5 is not, this resistor is not between any two loops. Okay. It is just in loop 3 or mesh 3 we can say. So what is the voltage across R5? Resistance value is how much? 1000. 1000 into what is the current in that particular mesh? Current is I3 current. So 1000 into I3, that is equal to 0 because there is no voltage source here. Okay. This is it. Okay, so algebraic sum of voltage drops in mesh 3 is equal to 0. So I will just remove this circuit. Okay, now we have written this equation. So 2000 I3 minus I1, you just expand it. 2000 I3 minus 2000 I1. 1000 I2 plus I3, you just expand it. 1000 I2 plus 1000 I3 plus 1000 I3. This is it. Now what is I1 minus 2000 I1? You just keep it as it is. You can see here only 1000 I2 is there. You just write it as it is. Minus 2000 I1 plus 1000 I2 plus, you can see 3 I3 currents are there. How much? What are those? 2000 I3 plus 1000 I3 plus 1000 I3 means total 4000 I3 is equal to 0. So this is our equation 3. You just write it down. As soon as you complete, just inform. Now we have three equations. You can use a scientific calculator. You can substitute these three equations in that scientific calculator, and if you solve it, you will get I1 equal to, solving equation 1, 2 and 3, you will get I1 equal to 0.0115 amperes. You just convert that into milli, you will get 11.5 milliamperes. I2 you will get 0.00461 amperes. In the calculator you can convert that into milliamperes, that is 4.61 milliamperes. I3 you will get 0.00461 amperes. You convert that into milliamperes, you will get 4.61 amperes. So consider I1, I2, I3 as equation 4, 5 and 6. Now we have I1 current, I2 current, I3 current. We can determine the voltages across each resistor. Total 5 resistors were there. I don't know whether you have observed or not. So if you might have carefully observed, there were total 5 resistors. So let us determine the voltage drops across each resistor. So I am hoping that you have completed writing the equations, I1, I2, I3 values. I hope you have written. Now let us calculate the voltage across each resistor. So what is the voltage across resistor R1 is R1 whose resistance value is how much? 2000 ohms. Now by applying Ohm's law we can say what is equation of VR1, voltage across resistor R1. It is I1 minus I3 or I3 minus I1 into R1. VR1 is what? Either I1 minus I3 or I3 minus I1. That's why I have written this symbol difference. This symbol is not minus, it is the symbol of difference. Okay. So it is a symbol of difference. You can see carefully, if you just carefully observe, this is not minus. This is difference symbol. Okay. You can write there either I1 minus I3 or you can write I3 minus I1. So VR1 is equal to I1 difference I3 into R1. So what is I1 value? Just now we have calculated, that is 0.0115, and I3 value is 0.00461 into R1 value is how much? 2000. Substitute it, solve it, difference of 0.0115 and 0.00461. What do you get? You will get 0.00689 into 2000. You just solve it, you will get VR1 is equal to 13.78 volts. So VR1 is equal to how much? 13.78 volts. स्लो में रॉड है, रॉड है ना, स्लो में रॉड के बता ऊपर रॉड. Okay, similarly, let us see the voltage across R2. What is R2 value? It is 1000 ohms. Okay, now applying Ohm's law to determine the voltage across R2. What is the formula? VR2 we have already seen. It is R2 into I1 plus I2. Okay, so we have already seen this equation. So same equation we are going to consider actually. So VR2 is equal to what? What is I1 value? 0.0115. I2 is 0.00461 into R2 value is 1000. So 0.0115 plus 0.00461, how much is it? 0.0161 into 1000. Just solve it. VR2 you will get 16.11 volts. Okay, so I'll just give you a minute to copy it down. Okay, now let us determine the voltage drop across R3. So voltage across R3, R3 is how much resistance value is? Resistance value is 1000 ohms. Okay, so what is the voltage drop across R3? VR3 is equal to what? R3 into I2 plus I3. So VR3 is equal to what is I2 value 0.00461, I3 value is 0.00461. So 0.00461 plus 0.00461 into what is R3 value 1000. So add these two 0.00461 plus 0.00461. If you add, you will get 0.00922 into 1000. If people can, if you have calculator in your hand, you can check the answers. Okay, so blindly, no need to rely on me. Okay, so even my calculations can go wrong. You can do the calculations, and whatever values that you get, you can mention in the chat box. So, VR3, what do you get? 9.22 volts. So VR3 is 9.22 volts. I'll just remove the inks and I'll just leave it for a minute. Okay then. I hope you have completed. Next, let us go for VR4. So what is the VR4? It is the voltage across resistor R4 whose value is 1000 ohms. So by applying Ohm's law, what is VR4? VR4 is equal to R4 into I2. Okay. So VR4 is equal to what is I2 value 0.00461 into R4 is 1000. So just multiply it, you will get VR4 is equal to 4.61 volts. So I hope you have completed. So now what is the voltage across R5? So voltage across R5 whose value is 1000 ohms. Apply Ohm's law. So VR5 is what? Current I3 into R5. What is I3 value? 0.00461. R5 value is 1000. Just multiply it. VR5 equal to 4.61 volts. Okay, VR5 is completed. So that's it. We have calculated the voltages across each resistor. If anyone, if you want me to repeat any concept, any part of this topic, you can mention. Actually, we have to discuss KIRCHHOFF'S current law also. I think I won't be able to complete today. So I will complete the KIRCHHOFF'S voltage law for today's session, and if possible, I may take tomorrow also, and I will discuss KIRCHHOFF'S current law tomorrow. So let us see the theoretical proof. So let us see the theoretical proof. For theoretical proof, I have followed two methods. Those two methods I am going to discuss now. So whichever method you feel easy, you people can follow that method. No need to follow both methods. Okay, you can follow only one method. So let us start with method 1. Okay. Let us start with method 1. There are two methods. You can follow any of those two methods. So theoretical proof, method 1, theoretical proof. So first of all, to verify KVL. So what is the KVL equation in mesh 1? What was it? Earlier we have written, already it is there. I have written in the earlier slide. What is it? VR1 plus VR2 is equal to 30. So what is VR1 value that you have got? 13.78. VR2 value that we have got 16.11. That is equal to 30. So you just add VR1 and VR2, you will get 29.89, which is approximately equal to 30. Okay. So according to KVL, the algebraic sum of voltage drops in a closed path must be equal to the algebraic sum of the source voltages. So if you see here, the algebraic sum of voltage drops is approximately equal to the source voltage value. Hence what? KVL in mesh 1 is verified. Okay, hence what? If you write this is more than sufficient. Okay, if anyone is noting it down, if you write hence KVL in mesh 1 is verified, that is more than sufficient. No need to write the whole statement. I have written a lot. No need to follow me. You just write KVL, hence KVL in mesh 1 is verified. I will erase all links. So simply what you have to do is, you just write, if you are copying it down, you just write this line. After that, write these three equations. And after that, you can mention, hence, KVL is in mesh 1 is verified. That's it. Okay. So I hope you have completed. Okay, I hope you have completed. Now let us verify KVL in mesh 2. Okay. To verify KVL, where is my cursor? It is here. Okay. I'm unable to see. To verify KVL in mesh 2, what is the voltage drop equation or mesh equation that we have written earlier? What was it? VR2 plus VR3 plus VR4 is equal to 30. Okay. VR2 plus VR3 plus VR4 is equal to 30. What is VR2? 16.11. VR3 is 9.22. VR4 is 4.61. So 16.11 plus 9.22 plus 4.61 is equal to 30. Okay. So add 16.11, 9.22 and 4.61, you will get 29.94, which is approximately equal to 30. So algebraic sum of voltage drops in a closed path is equal to what? Algebraic sum of the voltage source values. So we can say, hence KVL in mesh 2 is verified. No need to write this whole statement. Just write this from here to here. If you are copying it down, if anyone is copying it down, you can write that. That is more than sufficient. Okay. So just write from here to here and from here to here. That is more than sufficient. Now let us verify KVL in mesh 3. So to verify KVL in mesh 3, so in mesh 3, what are there? There are three, there was no source, so it was 0. So there were three voltage drops were there in mesh 3. Okay. So there were three voltage drops in mesh 3. Okay. So what we have, if you observe there, so R5, okay, so voltage drop across R5, isn't it? Voltage drop across R5, what is it? So where is my cursor? Yeah. So voltage drop across R5, voltage drop across R3, and voltage drop across R1. Okay, so in all this, we have what we have observed earlier is that we are what is it? VR3 and VR1 both are in are the resistors between two meshes, whereas VR5 is only in mesh 3. That's it. Okay, so just take the voltage drops. Okay, so algebraic sum of voltage drops must be equal to 0. So here, when you consider VR3, you must consider I3 minus I2. Okay, so for VR3, actually here both the current directions were same. You might have added those two currents. Okay, for VR5, the only one current was there. But for VR1, the current directions were opposite to each other. So according to Kirchhoff's voltage law, the algebraic sum of voltage drops in a closed path must be equal to 0. So if you observe here, if I simply add all these voltage drops, will I get 0? Simply if I add all this voltage drop, I will not get 0. Okay. So the current directions, depending on the loop direction, the current directions will change. Okay. Depending on the loop that you consider, loop current direction that you consider, current directions will change. Okay. And voltage drops, you may get positive or negative. Okay. So here, in order to verify Kirchhoff's voltage law, if VR3 and VR5 are negative, okay, if VR3 and VR5 are negative, and if you add them with 13.78, that is VR1 voltage, okay, then you are getting approximately 0 value, that is 0.05, which is approximately equal to 0. So then KVL is verified. So whatever voltage drops that you get, okay, in a closed path, okay, so depending on the current direction that you take, voltage drop, you may get positive or negative. So whatever voltage drop that we got earlier, all were positive, isn't it? We didn't get any negative value. So but if you consider all positive, so in this mesh 3, the KVL will not be verified. Okay, so in order to verify KVL, these two V3 and VR3 and VR5 voltage drops must be negative, then only KVL will be verified. Okay, so you just see 0.05 is equal to approximately equal to 0. So we can say, so I think here it is mesh 3. I just copied from previous slide. I forgot to change this. So hence KVL is verified in mesh 3. Okay, KVL is verified in mesh 3, not mesh 2, it is mesh 3. So this is one of the method, which is very simple method. Okay, so you can follow that method. That is more than sufficient actually. But I have written one more method here. I'll discuss that also, so that if you want, you can follow that method also to write the theoretical proof for this circuit that I have considered here. So this is one method. So see, I have written OR here. So you can follow any method, either first method or second method. So first method is simple actually. Let us see the second method also. So OR, I have written OR. So what is method 2? Theoretical proof. Okay. So another method 2. Let us see the theoretical proof for the given circuit. So applying KVL in mesh 1. Okay. So substitute equation 4, 5 and 6 values in equation 1. You already have equation 1, 2, 3. Isn't it? Substitute 4, 5, 6 in equation 1. Okay. 4, 5, 6 were what? 4, 5, 6 are the I1, I2, I3 values. Isn't it? So this is our equation 1. This is equation 1. So in this equation substitute I1 value, I2 value and I3 value simply. Okay. So substitute I1, I2 and I3 value. So 3000 into I1, what is it? 3000 into I1 is 0.0115 plus 1000 into I2 is, I2 value is 0.00461 minus 2000 into I3. Okay. So 2000 into what is I3 value? 0.00461 equal to 30. Equal to 30. So 3000 into 0.00115. Okay, 3000 into 0.0115, sorry. 3000 into 0.0115, what is it? 34.5. 1000 into 0.00461, what is it? 4.61. 2000 into 0.00461, how much is it? 9.22 equal to 30. So you just solve this, you will get 29.89, which is approximately equal to 30. So what we can say? Hence Kirchhoff's voltage law, KVL in mesh 1 is verified. Okay, we can say KVL in mesh 1 is verified. So I might have written in the next line, next slide. So I don't know whether you are writing it down or not. So method, if you have written method 1, that is more than sufficient. No need to go for method 2. So if whichever method you feel comfortable and you feel it is more easy to understand. So what you have to write it? Hence KVL in mesh 1 is verified. That is more. This is more than sufficient. KVL in mesh 1 is verified. Okay. Now let us verify KVL in mesh 2. Now again same thing. Substitute equation 4, 5, 6. Equation means not equation. I1, I2, I3 values. Okay. Substitute 4, 5, 6 in equation 2. So what is our equation 2? This is our equation 2. This is our equation 2. I will erase all the ink. Okay. What is our equation 2? 1000 into I1 plus 3000 into I2 plus 1000 into I3 is equal to 30. So substitute I1 value, I2 value, I3 value in equation 2. This is our equation 2. So substitute I1, I2, I3, 1000 into, what is I1? 0.0115 plus 3000 into, what is I2? 0.00461 plus 1000 into I3 is what? 0.00461 equal to 30. So 1000 into 0.115, how much do you get? 11.5. Okay, 1000 into 0.115, what do you get? 11.5. 3000 into 0.00461, what do you get? 13.83. 1000 into 0.00461, how much do you get? 4.61. So equal to 30. Now add all these three. So if you add, what do you get? 29.94, which is approximately equal to 30. So what we can say? Hence KVL is verified, isn't it? You can say hence KVL is verified in mesh 2. Simply you just write this. No need to write all these 3 lines if you are noting it down. So just write only this. Hence KVL is verified. Hence KVL is verified in mesh 2. I am about to conclude. Within 1 minute, I will complete this theoretical calculations of Kirchhoff's voltage law. Okay, I am going to the next slide. Okay then. Next, to verify what? KVL in mesh 3. Substitute what? I1 value, that is equation 4, 5 and 6. I1, I2 and I3. 4, 5, 6 means 4 means I1 value, 5 means I2 value, 6 means I3 value. Substitute 4, 5, 6. That is I1, I2, I3 in which what? In equation 3. So what is our equation 3? Equation 3 is minus 2000 I1 plus 1000 I2 plus 4000 I3 is equal to 0. So what is our equation 3? This is our equation 3. This is our equation 3. I'm unable to write. So what is it? So minus 2000 I1 plus 1000 I2 plus 4000 I3 is equal to 0. So substitute 4, 5, 6 in this. So 2000 into what is I1 value? 0.0115 plus 1000 into 0.00461 plus 4000 into 0.00461 equal to 0. Now add all these terms. Now first of all multiply. Minus 2000 into 0.00115 is minus 23. 1000 into 0.00461 is 4.61. 4000 into 0.00461 is 18.44. That is equal to 0. So just add all this, you will get minus 0.05, which is approximately equal to what? 0. So what we can say, hence KVL in mesh 3 is verified. So this is the second method for the theoretical proof of your Kirchhoff's voltage law. So these are the two methods to for the theoretical proofs of Kirchhoff's voltage law. You can follow either method 1 or method 2. No need to follow both the methods. Whichever method you feel is simple and easy, you can follow it. Anyone, if you have any query, just mention in the chat box. I will give answer to that. Anyone, if any part was you were unable to understand, whether you were able to understand or not, you can mention in the chat box. If you want me to repeat anything, any doubt if you have, you just mention in the chat box. I will clarify that doubt. So actually I wanted to discuss both Kirchhoff's voltage law and current law theoretical calculations. Even in the first slide I just mentioned that theoretical calculations of Kirchhoff's voltage law and current law, but it took almost 1 hour for me to discuss the theoretical calculations of Kirchhoff's voltage law. So I won't be able to discuss the Kirchhoff's current law theoretical calculations in today's session. Tomorrow I will take another session to discuss Kirchhoff's current law. Okay, anyone, if you have any doubt, I'll wait for a minute. If you have any doubt, you just mention in the chat box. Okay then. So if anyone have not yet subscribed, you just subscribe this channel. If you have understood, just click on the like button so that this video can reach as many people as possible who are in need of. Okay. So, okay then.